Am I audible? Okay. Assuming that I'm audible, right? Actually, what happens here, I cannot hear what you speak because only my mic is enabled here. Okay, fine. Thank you. Thank you for the acknowledgement. Yeah, right, my friends. Thank you. Right. See, yesterday's class, my friend, it was a pretty long session yesterday we had, right? Okay. So, what exactly we have seen yesterday, I'll tell you. We started with insulation. After understanding the structure of atmosphere, we started with insulation. Somewhere we understood what exactly is insulation. Incoming solar radiation, we were calling it as what? Insolation, my friend. Okay. And somewhere I said, though this insolation is almost static throughout the year, what varies from place to place and time to time is the distribution of insolation. Few places insolation is concentrated and few places the insolation is distributed, my friend. Okay. So somewhere we have talked about the reasons why exactly there is a distribution of insolation, right? At least three very important reasons we have taken it. Angle of sun's rays, distance traveled by sun's rays through atmosphere we have taken it. And of course, the length of the day also we have taken it, my friend, right? Season cycle. Angle of sun's rays is very important, my friend. What makes the ultimate difference is the angle at which the sun rays is falling. This is ultimate, primary, number one. Okay. So wherever you experience a high sun position, my friend, high sun position, normally, right, see, for example, we should fix some value, right, to say whether it is a high sun or low sun. Normally we say when the sun's rays falls over 45 degree with respect to the surface of the earth, you call them as what? High sun position, correct? Similarly, when I talk about low sun position less than 45 degree, we call them as what? Low sun position. So somewhere, right, we know the fact, my friend, wherever you have the high sun position, there all the energy gets concentrated, correct? So that the temperature will be very high. Wherever you experience a low sun position, there all the energy gets distributed, correct? As the case, what you have is a, right, very less temperature in general, my friend. So where all we applied this logic, lower latitudes and higher latitudes, we have analyzed this logic, right? Summers and winters we have taken it, correct? And not only summers and winter, my friend, we also talked about what? Why exactly afternoon it is, say for example, it is sunny, and say for example, morning it is not so great in its temperature. The same reason we have taken it, my friend. Okay. And apart from that, we also talked about the distance traveled by sun's rays through atmosphere. So when I talk about distance traveled by sun's rays through atmosphere, somewhere I understand, right? High sun position always travel a lesser distance in comparison to a slanting sun's rays, my friend. So slanting sun's rays always travel a longer distance to reach the surface of the earth. So yesterday's class we said more is the distance traveled by sun's rays through atmosphere, more will be the loss of insolation, my friend. Okay. So both pictorially we have justified, am I right? Somewhere we have taken one example and we have seen it. And of course, I said, my friend, even the length of the day also makes a means difference. Okay. Slight difference. See, same 90-degree high sun position, if you experience with an elongated, say for example, length of the day, somewhere I understand temperature is going to be higher. Okay, right. So all the factors we have taken and why insolation is different from place to place we have seen. Right, my friend. Then, right, when talking about atmospheric temperature, insolation resulted atmospheric temperature we have taken. What is atmospheric temperature? Heat present in the lower reaches of atmosphere. This is what you call them as what? Atmospheric temperature. Okay. So somewhere we said, my friend, right? And about atmospheric temperature, the immediate source, the direct source of atmospheric temperature is what? Terrestrial radiation. Because we know the fact, sun's rays will be heating the surface, correct? Insolation do not heat up the atmosphere directly. It will heat the surface, and the energy or the heat that is liberated from the surface is the one which is going to heat the atmosphere, right? That's the reason I said, my friend, the direct source or immediate source is what? Terrestrial radiation. Okay. Then we talked about a very important concept called as heat budget, my friend. What is a heat budget? A delicate balance that exists between incoming solar radiation and outgoing terrestrial radiation is called as what? Heat budget. Okay. So what is incoming? Somewhere we know. What is incoming is what? Insolation. Insolation is known by different names, my friend. You call them as insolation. You call them as what? Short wave radiation. You call them as what? Ultraviolet radiation. Whatever way you call them as, you can call them as. Correct? So somewhere I know insolation is that energy that comes from the sun. But somewhere we know, my friend, it is not that all 100% of insolation what comes to the earth as a system finally do not come to the surface of the earth. Only half the insolation finally reaches the surface of the earth, my friend. Only half. Correct. Now, what are the different ways that insolation is lost? Somewhere we have said, right? High in the atmosphere, 14% of insolation is absorbed by what? Ozone. Ozone which is present in atmosphere. Tropos means, to be very precise, stratosphere. Correct. Only 86% comes to troposphere, my friend. In that 86%, 8% is scattered by aerosol. Right. Remaining 80%, 27 is reflected back by cloud cover. What we have is remaining only 53. Only 53 reaches the surface. Even when this 53 reaches the surface, 2% is reflected back by ice caps. Just 51%, my friend. What you call them as simple majority, right? Political terminology, you call them as what? Simple majority. This is what finally reaches the surface of the earth. And all this, right, 51%, my friend, it is liberated back to exo-atmosphere. Right? It is liberated back to exo-atmosphere. Right, my friend. So, when I talk about this liberating back to exo-atmosphere in the name of terrestrial radiation, 17% of it escapes directly, my friend. What is remaining? Remaining 34. This 34 is temporarily absorbed by gases like carbon dioxide. Is it only carbon dioxide? If you ask me, no. All greenhouse gases put together, right, say for example, absorbs or retains this 34% of, right, total energy that what Earth as a system receives, my friend. Okay. So somewhere we have seen the heat budget as a concept. Okay. So after completing this heat budget, my friend, we were talking about the horizontal distribution of atmospheric temperature. Okay. Right. What are the different factors which results in the variation of temperature from place to place? Correct. Various factors we have seen. Among them, the most important factor are two, my friend. Number one, it is latitude, and number two, it is altitude. That's the reason, my friend, hill stations are always colder. Why hill stations are always colder? Because of what? Altitudinal difference. Okay, right. Then we also talked about continentality. What is continentality? The distance from sea, you call them as what? Continentality, my friend. Okay. So based on latitude, how exactly the entire earth can be divided, at least the Greeks classification I am just given it. Okay. The lower latitude, you call them as what? Torrid region. Right. Our parlance, we call them as what? Tropical region. Mid latitudes, you call them as temperate region, and beyond this temperate region, what you have is what? Frigid zones, my friend. Right. What you have is what? Frigid zones. Okay. Right. Now, apart from this latitude, my friend, latitude, what you have is what? Altitude, my friend. Right. What you have is altitude. Altitude is nothing but what? Height. Okay. You increase the height, temperature decreases. Okay. So somewhere I know this rate of decrease of temperature is almost static throughout the atmosphere. What is the rate at which this atmosphere decreases? If you ask me, 6.5 degrees centigrade, it decreases. Okay. Every 1 kilometer you increase the height, temperature decreases by 6.5 degrees centigrade. Okay. Then we also talked about continentality. And somewhere I said water has the ability to maintain temperature, my friend. Right? Water has high specific heat capacity, we said. Right? Water maintains temperature. In what way? Right? Water do not becomes ultimately hot, very hot, or water do not becomes extremely cold. Water always moderates temperature, my friend. That's the reason. Coastal regions will not become too hot, right? And similarly, the coastal regions will not become too cold. Okay. And my dear friends, if at all, if you somewhere, if you are there at a coastal region, and if you still complain that it is very hot, you should go to the interiors and check that how hot the temperature can be. Okay. So somewhere, my friend, coastal regions will not become too hot, or the coastal regions will not become too cold. Correct? Why? Water maintains temperature. So wherever there are few parts of land which comes under the influence of water, correct? We call them as what? Maritime effectivity. But as you move away from water, this land will behave purely like that of land. Okay. That's what you call them as what? Continentality. Okay. Right, my friends. Okay. Then we also talked about the influence of ocean currents. Okay. We talked about ocean currents, my friend. So now about ocean currents. Actually, there are only two types of ocean currents based on temperature. You call them as warm currents, you call them as what? Cold current. Okay. See, there is no clear-cut temperature suggesting that this is warm and this is cold current. No. How do I say warm and cold current? Simple. Warmer than the adjoining water, warm currents. Warm currents are always sourced from lower latitudes. Whereas if it is colder than the adjoining waters, you call them as cold current, and cold currents are always sourced from higher latitudes. That you will see it. Later also I will be explaining the same, my friend. Okay. And if at all, if you find a pattern, always that one pattern exists. What is that pattern that exists? The western side of the ocean will always be a warm current. Correct? Right, my friend. And that's the reason I said west is warm. Just somewhere, try to remember west is warm. But somewhere I know, my friend, this reference when I say west and east, this is with respect to the ocean itself. With respect to the ocean, west is warm and east is cold, my friend. Okay. So whichever place comes under the influence of warm current, the temperature will increase. And whichever place comes under the influence of cold current, the temperature will decrease, my friend. Okay. Then we also talked about the influence of local factors, my friend. Okay. So when we talk about local factors, cloud will play a very important role. Okay. So somewhere I know cloud during the daytime will decrease the temperature and during the night time will increase the temperature. My dear friends, very important. This cloud cover, you have to keep it in mind. Somewhere you have to remember one thing. Cloudy nights will be warm. Where all you can apply this concept, I'll tell you later. Even temperature inversion, you can apply this concept. Dew and frost formation, you can apply this concept. Okay, I'll tell you later, but somewhere you kindly remember this statement, right? When I say during night time, what happens, right? Night, cloudy nights will be what? Warm, my friends. Cloudy nights will be warm. Okay. So somewhere always remember, cloudy nights will be warm. Only cloudy days will be colder. Okay. Why cloudy nights are warmer, if you ask me? The reason is very simple. Because this terrestrial radiation is reflected back by cloud. Right. The heat is not allowed to escape to the exo-atmosphere. Right. It means what? See, surface is the one which is absorbing the heat. Now the surface is releasing the heat. Correct. This heat which is released by the surface, if it is escaping to exo-atmosphere, then no problem. Okay. If it is not escaping, it will get trapped, my friend. That's what you call them as what? Right. That's the reason I said cloudy nights are always warmer. Okay. Right, my friend. Then we also talked about the water vapor. Water vapor behaves more like that of cloud itself. Okay. Then finally, we also talked about the case of aerosol, my friend. And just before we concluded the class, right, we were talking about temperature inversion. What is temperature inversion? Normally, when you increase the height, temperature should decrease. Correct? But under certain circumstances, the temperature also increases with increasing height. This deviant character, you call them as what? Temperature inversion, my friend. Okay. So today I told you the temperature inversion, again I'll be telling you, right? I'm going to just dictate what is that condition, where exactly you're going to experience temperature inversion. So we'll just start with it, we'll write it, then we'll proceed to the further study, my friend. So today's class, again, you know what is temperature inversion. Only thing is that formally we should write what is temperature inversion. Okay. Now, my dear friends, what is temperature inversion also you know. And one more thing, my dear friends, see. My dear friends, see, I am just giving you a situation. Yesterday, somewhere we had an idea what is temperature inversion. Okay. You increase the height in troposphere. Normally, what happens? Temperature decreases. But I am talking about a situation where temperature also increases with increasing height. Okay. That is what I call them as what temperature inversion. Correct. Now, here also, somewhere, okay. I'm just giving you a condition. When I talk about surface condition, normal condition, what is a normal condition? If surface condition is warm and upper air condition is cold, right, you call them as normal condition. Then what is temperature inversion? Surface condition should be cold and upper air condition should be warm, my friend. That is what I call them as what? Temperature inversion. Correct. It means near surface means not the earth itself. Am I right? I am talking about near the surface. Right. Atmosphere. We are going to study about atmosphere. Right. Now you have to tell me, my friend. Yesterday I have just given you a clue. What is a clue? When and where temperature inversion can take place. When you ask me when, right, I can say that it is during winter nights, because winter night is that time when the atmospheric condition will be become extremely cold. Am I right? Winter nights, correct? And where, if you ask me, normally in polar region, everything is fine. Now I have a very simple question for you, right? Just answer me with it. If at all, if you have a cloud, right? Very carefully assess my sentence, right? If you have a cloud during night time, will temperature inversion take place? If you have a cloud during the night time, will temperature inversion take place? That's the question. Answer is very simple, my friend. Either you can call it as yes, or you can call it as what? No. That's it. Right. Few of the answers. Right. Would like to read it. If you have cloudy nights, if you have cloud during the night time, can the temperature inversion take place? That's the question. People said yes, but I am telling you, my friend, answer is big no. I'll tell you why. Because if you have cloud during the night time, that's the reason I have just brought moon, right? If you have cloud during night time, my friend, surface condition will not become warm. It will become, sorry, it will not become cold. It will become warm, my friend. Why? Because cloudy nights, you know, it is warmer. Correct? So near surface region will be warm. Am I right? But what you need is a cold condition. Okay. My dear friends, so that's the reason. Cloudy nights, you will not experience temperature inversion. Normally, they say temperature inversion can happen only during a cloudless night. Very important. Okay. See, somewhere you can, I mean, somewhere you'll be remembering, right? Is this phenomena so complex to remember, understand? Nothing. Somewhere I said, for temperature inversion to take place, ground condition should be very cold. You know the fact that if you have clouds during night time, you will not have this cold condition, right? Because you know cloud will increase the surface temperature, or day means night temperature, correct? That's the reason, my friend. Okay. Now what you can do, you can write what exactly is temperature inversion. Very important, both for prelims and mains. Both are important, my friend. You can write it. You can write it. I'll slowly dictate it. With increasing height, with increasing height, temperature temperature generally decreases. With increasing height, temperature generally decreases. Generally decreases in troposphere. In troposphere. Please rename to identify you. So this message is not for me. Okay, right. Got distracted by a message. Okay, whatever it is. Yeah. Yeah, I was just talking about temperature inversion. Okay, yeah, man. I'll repeat again. I simply said with increasing height, temperature generally decreases in troposphere. However, however, under certain circumstances, under certain circumstances, temperature, under certain circumstances, come on, the temperature may also increase, may also increase with increasing height, may also increase with increasing height. This phenomena, this phenomena is called as temperature inversion. This phenomena is called as temperature inversion. Further, you can write temperature inversion. Temperature inversion is common temperature inversion is common in polar region, in polar region and mid latitudes, polar region and mid latitudes. Mid latitude somewhere around, you can write it as what? 60° north and south. 60° latitude. Temperature inversion is common in polar region and mid latitudes throughout the year. Perennial presence throughout the year. Throughout the year. I repeat, temperature inversion is common in polar region and mid latitudes throughout the year. Right? Further, you can write. It is also common along. It is also common along tall mountain chains. It is also common along tall mountains with deep valley. It is also common along tall mountains with deep valley. Okay. Air drainage facilitates. What is this air drainage? I'll tell you later. Okay, somewhere you can write it. Air drainage facilitates temperature inversion. Air drainage facilitates temperature inversion along the slopes of the mountain. Along the slopes of the mountain during morning time. During morning time. My dear friends, whatever I said, you may not understand as of now because I have not explained it. What I'll do, we have a topic called as local winds. There I'll be talking about something called as mountain breeze and valley breeze. There I'll be explaining this concept. Okay. So I don't want to deviate it. So somewhere I said, right, temperature inversion also is also common along tall mountains with deep valleys, right? Air drainage facilitates temperature inversion along the mountain slopes. Correct. What is the statement? What is the meaning of it? I'll explain it later. Okay. And finally, you can also write, my friend, temperature inversion. Temperature inversion is also common. Is also common during long winter nights. Long winter nights. Within bracket, you can write it as what? Cloudless nights, my friend. Cloudless nights. Okay. So it's common during long winter nights and cloudless nights. Right? Right, my friend. So what is temperature inversion? Where all we experience temperature inversion? Everything we have taken it. Very important concept. Okay. So with temperature inversion being completed, so my dear friends, we are completing what? Temperature in all aspects. Okay. So what we have done, right? What we have done, I'll tell you. Insolation we have completed, temperature we have completed, and now it's time to talk about pressure system, my friend. Okay. Temperature resulted pressure difference. Okay. We'll call it as what? Pressure system or atmospheric pressure. We call them as what? Atmospheric pressure. So when I talk about atmospheric pressure, what is this atmospheric pressure? I'll tell you. See, atmosphere also has a weight, am I right? It has a mass. Okay. This weight will be acting on the surface, my friend. Assume that, see, I am taking some section of atmosphere, my friend. Okay. I'm taking some section of atmosphere. Okay. This atmosphere, assume that this is surface of the earth. Correct. The entire atmosphere, the section of the air column will be having the weight of its own, and this weight will be acting on the surface, my friend. Okay. The weight that is acting on the surface of the earth, right? This is what you call them as what? Pressure, my friend. This is what you call them as what? Pressure. Correct. Some forces apply. See, for example, assume that, see, I have my hand. Okay. Some weight, if at all, if some weight is acting on it, I'll say, right? Normally we say, right, I don't put so much pressure on me, something like that. Okay. So what is the pressure? Pressure means what? Some weight which is being acting on the surface, I call them as what? Pressure. As simple as this. Okay. Right, my friend. We call them as what? Everywhere there's a pressure. Correct. So pressure only acts on that surface. Okay. So what is an atmospheric pressure? Somewhere you can write it. Somewhere you can write it. Weight of atmosphere. Weight of atmosphere acting on the surface of earth. Weight of atmosphere acting on the surface of earth is called as atmospheric pressure. It's called as atmospheric pressure. So weight of atmosphere acting on the surface of the earth is called as atmospheric pressure. Right. So what is this atmospheric pressure? Now I have an idea. My dear friends, few things I have to understand very much, my friend. Right. With increasing height, pressure always decreases. Somewhere you can write it as a golden principle. Okay. With increasing height, pressure always decreases. Okay. Why I am saying this statement at the very beginning itself, I'll tell you, because normally we tend to develop a doubt, right? What is the doubt? I'll tell you, because you know the relation between temperature and pressure. Normally we say that temperature and pressure, they are inversely proportionate to each other. It means what? Higher is the temperature, lower will be the pressure. Okay. Higher is the temperature, lower will be the pressure, my friend. Correct. Right. This is what normally happens. Okay. Now, what is the doubt we'll develop? I'll tell you, my friend. If you increase the height, you know that temperature also decreases. You increase the height, right? You understand that pressure also decreases. So it appears as though this temperature and pressure, they are directly proportionate to each other. Am I right? That's the doubt what you will be having it. Okay. Now let me tell you, my friend, why exactly, right? There is a kind of a fallacy here. Fallacy here in the sense, see, whenever I am just comparing pressure of two different height should never be compared, my friend. Should never be compared. Pressure of only same height should be compared. Okay. Pressure of different height should never be compared. Okay. Say for example, whenever I am just say you are there at the surface. If you are there at the surface, okay. Say for example, I can have some place 1, I can have some place called as 2, A, B, whatever you call them as. If I am just comparing the pressure only between these two places, I will be comparing the pressure. I will not compare a pressure system which is there at the surface with the pressure system which is there at tropopause level. No, that is a very bad comparison. Okay. So let me tell you, my friend, golden rule number 2, pressure should be compared only with the same altitude. Pressure between altitude shall never be compared. This is golden rule, my friend. Okay. Right. Right. What is pressure? We have an idea. And my dear friends, when I talk about pressure, how we can classify the pressure system or pressure in general, atmospheric pressure. Normally, there are two types of pressure, my friend. You call them as what? High pressure. And 2, you call them as what? Low pressure, my friend. You call them as what? High pressure and low pressure. What is high pressure and what is low pressure? Approximately, I'll just give you a simple way of identifying the difference. Okay, see, my dear friends, if you ask me what is an average pressure, okay, everything you have an average pressure. In that regard, if you ask me what exactly is the average pressure, right? Normally we say average atmospheric pressure is 1013.25 millibars, my friend. Millibars, right? So MB means millibars. If you want to write it within bracket, you can write it. MB means millibars. Millibars. Okay. 1030.25 millibars. Okay. So this is the average pressure what we have. Okay. And my dear friends, if you ask me, right, see, what is this 1013? How should I understand? If you come across one bar is nothing but what? 1000 millibars, my friend. So approximately the average atmospheric pressure is approximately 1 bar, my friend. 1 bar. See, very easily you can remember. Sarcastically, I used to say, bar is a unit for measuring pressure, my friend. Correct, bar. That's the reason sarcastically I used to say, pressure and bar is always related, my friend. Okay, right, whatever it is the case. Now coming here. And talk about high pressure. How should I understand high pressure? Any pressure system which has a value of more than 1013.25 millibars, you call them as what? High pressure. Any pressure system which has a pressure system or a value which is less than 1013, you call them as what? Low pressure, my friend. Okay. So I talk about this high pressure. And talk about this high pressure. We have at least 2 types of high pressure, my friend. If this high pressure is very large in size, correct? If it is not so intense, we call them as what? Wedges. If it is very small in size, very intense, we call them as what? Anticyclones. We call them as what? Anticyclones, my friend. On the other hand, when I talk about, say for example, low pressure system, large in size, not so intense, we call them as what? Trough, right? On the other hand, my friend, right? If it is very small in size, right? If it is very small in size, very intense, we call them as what? Cyclone. Cyclone is very important for us because syllabus explicitly mentions about cyclones, my friend. So again, when I talk about cyclones, right? You have two types of cyclones, my friend. One, I call them as what? Tropical cyclone. And two, you call them as what? Temperate cyclone, my friend. You call them as what? Tropical, and you call them as what? Temperate cyclones. These are the two different types of cyclones what we have. And my friends, we have to study about these pressure systems. Okay. So different pressure systems of the world we have to study about. First, what we'll do, we'll discuss about some of the very important wedges and troughs of the world. What very popularly we call them as what? Pressure belts. Okay. Then we'll be talking about cyclones at the later studies. Anticyclone we are not going to study. We are not, is not part of our syllabus. Okay. Right. Right, my friends. So we are going to study about pressure. And before studying about pressure, my friend, before studying about pressure, see somewhere I used this word called as bars, correct? Because I have used this word called as bars, let me ask you one few questions, my friend. Okay. You must be knowing it, correct? Only thing is that you have to tell me that what exactly is the meaning of these terms, right? Sometimes you come across the words like isobars. Okay, let me talk about isotherms. Any idea what is this isotherm, my friend? What do you mean by isotherm? Any idea? Any idea what is this isotherm, my friend? It's a line joining places having same temperature area. Pankaj, very good, fantastic. Used to map to show same temperature. Very good. Right, my dear friends. Most of the time, I would always say, geography. To understand geography, if you know the basic ideas about this English language, basic meaning of the common words, if you know, most of the concepts you can make it through. For example, why? Isotherm. Therm means temperature, iso means similar. It means what? It's the line joining the places having same temperature, my friend. Okay. Same temperature. Right. So isotherm is the line joining same temperature. Correct. So isotherm I understand. Now you have to tell me what do you mean by this isobars, my friend. Isobars. Any idea? What is isobars? See, don't go for the definition. Don't go for the definition. Right, very good. It is for pressure. Because just now I said bar is a unit for measuring what? Pressure. Bar is a unit for measuring what? Pressure, my friend. Okay. So this is for what? The places joining same pressure, right? Same pressure. Even this word, the same you can take it because you know it is same. Only temperature and pressure you can retain it, my friend. Okay. Very good. Isobars is for what? Pressure. Now I am just giving you two things, my friend. Okay, I am just giving you this word. What do you mean by this iso height? What do you mean by iso height, my friend? Any idea what is this iso height? What is this ISO height? Oh, very good. Okay, that's the reason I have just given you. My dear friends, on the face of it, by pronunciation, it looks as though it is the line joining the places having same height or altitude, but it is not height or altitude. It is having same rainfall or precipitation, my friend. Okay, so ISO height is very important. Somewhere you just mark it. Now comes the question. Okay, everything is fine. If that is the case, what is that line? We use it to mark the places having same height. We call them as what? ISO lines, my friend. You call them as what? ISO lines, or you call them as what? Contour. So contour is the one which almost is that concept which joins the places having same height or altitude, my friend. Okay, right. All this, what I have just given you is very important, my friend. Somewhere you mark it important. Okay, you mark it important. Okay. So isotherm is temperature, isobar is pressure, iso height is rainfall. Isoline or contour is the one, what you call them as what? It's for height or altitude. Okay, right. Right, my friends. So, coming to the pressure, just we went for a deviation, but a very important deviation, right? Very important deviation. Why it is important, that also I've just justified it. Okay, right, my friend. So, first, what we have to do? First, we have to discuss about some of the very important pressure belts of the world, right? Temperature induced pressure belts of the world. First, we discuss about this pressure belts, my friend. Okay, right. So, let me talk about the very important one. We call them as what? Pressure belts. Okay. So let me talk about the pressure belts of the world, my friend. Okay, first, all the troughs and wedges of the world, we'll take it. Very popularly, we call them as what? Pressure belts. Right, where what type of pressure system you have in this generally the global scenario, that's what we are going to discuss now. Okay, I'll show you, my friend. There are totally 7 pressure belts are there in the world. Where approximately where what, I'll show you. So as I said, there are 7 pressure belts in the world. Same information but in different terms. Okay. Right, my friend. So take this image for reference purpose. We'll make it very simple. See, there are totally 7 pressure belts of the world, right? 1, 2, 3, 4, 5, 6, 7. 7 pressure belts are there in the world, my friend. So what I'll do, either you take it as a circular one or you just go it for what? Maybe. No, I'll also take this circular. Instead of circular, what I'll do, I'll just go for rectangular classification. Okay. Easy, right? Easy way of representing. Am I right? And my dear friends, somewhere if you're there in equatorial region, my friend, I am taking it as one line, but assume that this is not a line, this is a region, my friend. Okay. Somewhere if you're there in equatorial region, okay, I'll take it as a belt itself, right? Why to confuse you? I'll just take it as a belt, my friend. Somewhere. If you're there in equatorial region, okay, north and south of equator, okay, north and south of equator, this is the place where you have a low pressure system, and this low pressure system we call them as what? Equatorial low, my friend. Okay, we call them as what? Equatorial low. within bracket itself, within the same thing, I'll just write it. We call them as what? Equatorial low. Okay. You have a low pressure system, and this low pressure system, you call them as what? Equatorial low. Okay. At 30° north and 30° south, my friend. 30° north and 30° south. We have a pressure system, we call them as what? Subtropical high. We call them as what? Subtropical high. Okay. Somewhere around 60° north and 60° south latitude, what we have is what? Subpolar low, my friend. Subpolar low. Okay. And at 90° north and 90° south, what you have is polar high, my friend. So 90° north and 90° south, what we have is polar high. Okay. So these are the 7 pressure belts what we have. Okay. Now it's very easy to remember. I'll tell you why it is easy to remember. Only one I have to remember, my friend. Right? You have to remember equatorial region. What you have is what? Equatorial low, my friend. Why you have equatorial low? Because throughout the year, what you're going to experience is what? A very high temperature. Okay. You're going to experience a very high temperature, and whenever the temperature is very high, obviously you know the pressure system is going to be low, my friend. Okay. So only thing is that you have to remember that equatorial region, what you have is a low pressure. And this low pressure, you call them as what? Equatorial low. And my dear friends, if you know that 0° is where I have equatorial low, every 30° you travel north or south, every 30° you travel north or south, the pressure system is going to get altered. Low pressure is going to become high pressure is going to become low pressure. See, low is becoming high is becoming low is becoming high. There is an alternate sequence of pressure system. Okay. And how to remember the name? Very simple. Tropic, 23.5°, you call them as what? Tropic of Cancer. Correct. Tropic of Cancer to Tropic of Capricorn is what? Very popularly we call them as what? Tropical. Tropic to tropic, you call them as what? Tropical, my friend. So 30° slightly just beyond this tropical region, so you call them as what? Subtropical, and the pressure is high. Similarly, 66° is Arctic region. All right, polar region. Slightly beyond polar region, what you have is subpolar. Slightly beyond the tropical, subtropical. Slightly beyond the polar, subpolar. Correct? Right, my friends. So, somewhere, how to remember the name also I have told you. How to remember the pressure system also I have told you. Every pressure system, what you experience is what? Alternate sequence of high and low, my friend. Okay. Right, my friends. Okay. So, equatorial low, subtropical high, subpolar low, and polar high. These are the pressure systems what you have. Okay. Right, my friends. Okay. So, what are the pressure belts we have? Approximately, we have an idea. Now, see here. You may have a doubt, right? How exactly these pressure systems are developed? Okay. This is one question. Number two, we have a relation. What is the relation between temperature and pressure? Temperature and pressure, they are inversely proportionate to each other. When I say they are inversely proportionate to each other, if you have a high temperature, pressure should be low. If you have a low temperature, pressure should be high. My dear friends, high temperature, low pressure works with equatorial region. Low temperature and high pressure works with polar region or polar region. But what about the rest two, my friend? Okay. Rest two, see for example, I talk about 30-degree north and south. Temperature is also high, pressure is also high. 60-degree north and south. Temperature is also less, pressure is also less, my friend. Okay. So that is how we have divided this pressure system further into two categories. What are they? We call them as what? Thermal direct. We are calling it as what? Thermal direct pressure system or pressure beds. And thermal indirect pressure beds. Okay. So I talk about this thermal direct and thermal indirect pressure belts, my friend. Okay. This word, this direct and indirect is very important. Okay. So it is thermal direct and thermal indirect, very important words. Okay. So thermal direct and thermal indirect. Okay. So what are the thermal direct pressure belts if you ask me? Whichever pressure belts establishes a relation between temperature and pressure. That's what you call them as what? Thermal direct pressure belt. What are they? Equatorial low, and two polar high. Equatorial low and polar high. Right? Both are the prominent example of what? Right. Thermal direct. Temperature is very high, so I have equatorial low. Temperature is very low, so I have polar high. And what about the remaining two, my friend? Temperature is also high, pressure is also high. Temperature is also low, pressure is also so. What are they? Subtropical high and two, it is equatorial low. Sorry, excuse me, subpolar low. It is subtropical high and subpolar low. So these are the pressure system which experience, I would say, there is no relation between temperature and pressure. Okay. Now, if you ask me how this thermal direct pressure systems or pressure belts was created, right? Somewhere you can write it. Right. These pressure systems are created, or you can write it, resulted due to thermal action. Due to thermal action. Now, what is this thermal action? Very simple, right? Temperature is inversely proportionate to pressure. And when you ask me how exactly this thermal indirect pressure system is created, right? They are resulted due to spin of the earth. Due to spin of the earth, right? Right. So what has created this pressure systems, if you ask me, it is the spin of the earth. Not only the spin of the earth, my friend. The distance between the polar high and equatorial low is also seen as one of the reasons. Okay. You write the spin of the earth, and within bracket you can, or you can write it separately, right? They are mechanically created layer. Okay. They are mechanically induced layer. They are mechanically induced layers. So somewhere it is resultant due to the spin of the earth, we said, right? And they are mechanically induced layer. Okay, right, my friends. Okay. So what is thermal direct and what is thermal indirect pressure system? Approximately we have an idea, right? What are the different pressure belts of the world? That also we have taken it. Okay, right. So what is atmospheric pressure? So we have seen in detail, my friend. Okay. What are the different pressure systems of the world? And one more thing, this is very, very important, my friend. Why I'll tell you. Whenever I talk about wind, wind always moves from high pressure to low pressure. Wind always moves from high pressure to low pressure. Okay. So if that is the case, only depending upon the location of this high pressure and low pressure, right, you can have the movement of wind, my friend. Okay, say for example, from polar high, you have the wind which is moving to subpolar low, right? From subtropical high, we have a wind which is moving towards what? Both the low pressures. See, from polar high, I have a wind which is moving towards subpolar low. From subtropical high, I have a wind which is moving towards subpolar low. Similarly, from subtropical high, I have a wind which is moving towards equatorial low. Am I right? So I understand, my friend, always wind moves from a high pressure to low pressure. Correct. So only depending upon the location of the high pressure and low pressure, we can better understand the movement of wind. Okay. So pressure system and pressure belt approximately where what we have an idea. Right. Now, my dear friends, with this idea, right, we are completed this pressure, approximately where what pressure. Apart from talking about low and high pressure, we know what is thermal direct and thermal indirect. Okay. Only thing is that cyclone, I will reserve it at last. I will reserve it at last. Okay. Right. Right, my friends. Now, we'll just move to the next concept. Pressure induced wind. Am I right? So coming to the next concept, we call them as what? Wind, my friend. Okay. And my dear friends, let me tell you, wind, mark it somewhere very, very important. Okay. Climatology itself, I say this chapter is very important. Very important. Important means very important. Because every third question in geography is going to be a climatology question. Okay. Now, apart from that, my friend, in climatology, what is the topic which is very important and what we have to concentrate more, if you ask me, it is wind, my friend. So you have to concentrate wind, right? Very important. We'll concentrate. Okay. Right, my friends. We just take 2 to 3 minutes break. I'll come back.